Hello system design enthusiasts. So today we will be studying about gap theorem. So this is lecture 4 in my series of system design videos. If you haven't already checked out my previous videos, please go and check them out once you're done with this video. Or if you want to know the basics, you can also check them out before watching this particular video. Right, and I've talked about load balancing, scalability, availability, and few other important concepts. I will provide the link to them in description. So yeah, stay tuned till last and let's get started. So gap theorem, right? When we talk about gap theorem, we are generally talking about always remember when the word gap theorem comes up, we are actually most of the time talking about distributed systems, right? So this concept is mainly for distributed systems. So we are talking about distributed systems, okay? And more so, remember, this is gap theorem is generally talked in terms of databases. So databases in distributed system, whenever someone talks about the gap theorem, distributed system and databases is what should come to your mind, right? Now, so in a distributed system, various things can go wrong. If you think about it, there are various things that can go wrong in a distributed system. For example, your servers can crash. Your servers can basically crash. Another thing that can occur is you can have a like disk failure. Your disk can fail. Another thing that can occur is there can be communication failure between nodes or network failure. There can be network failure. So how can you, so this things will make your system inaccessible. So how can a distributed system get the maximum out of whatever the resources it has? This is what cap theorem talks about. So there are three terms, as you already have guessed, in cap theorem, which is consistency, availability, and partition tolerance, right? Consistency, availability, and partition tolerance. Now let us talk about all of the three. So what does consistency means is, let's say you have multiple nodes in your system. Let me change the color. Yeah, let's say you have multiple nodes in your system: node A, node B, and node C, right? So all of these nodes will have the exact same data at the same time. So if you are coming to node A and asking for what is the value of x, let's say it returns x equals to 3. Then if you go and at the same time, if you would have asked in the node B, it will also return x equal to 3, and even the node C would have written x equal to 3. This makes your system consistent. So if you see, every read receives the most recent write or an error, right? So if A is returning an error when asked for a value of 3, B and C will also return the error. So it is like all of them are in sync with each other at the same time. This is what consistency means. Hope that clarifies. Now, what is availability? Availability means that whatever the request you are placing, if it is being placed to a non-failing node, then you will get a response. So let's say you have a system. Let us talk about this as a black box. This is your system, because user is not able to see the nodes within the system, right? So let's say you have A, B, and C in your system as well. And if the user is placing a request, let's say user placed the request to your system, then the user must get a response. That's it. This is what availability means. At all times, user, when he's placing the request, it should get a response. Even when there is a network failure, every request must terminate. Basically, user should always see a response. So your system should always be accessible, even when, let's say, B goes down, right? Let's say B goes down, C goes down, whatever the number of nodes go down in your system, but your system should still be accessible and return a response, which makes your system available. So if you see here, every request receives a non-error response without the guarantee that it contains the most recent write. So if it contains the most recent write, then we are talking about consistency. Okay. Now when we are talking about partition tolerance, what exactly it is? So basically partition is, let's say, there are multiple nodes in your system, like we already discussed. So for example, uh, yeah, when you have two nodes, they must be communicating with each other. In a distributed system, you expect nodes to be in sync with each other. So the if this communication breaks, then this is known as partition, okay, or a network failure, right? So both the nodes won't be able to communicate with each other. So when we're talking about partition tolerance, a system is partition tolerance even if it continues to operate, even if there are network failures or partition. Your system should continue to operate despite of network failures. So your system should be able to sustain whatever the number of network failures in your entire network. So in your entire network there can be multiple network failures, right? So if you can have A, B, C, D, and right, A, B, C, D, and if there is communication break between any two or three of them, then still your system should be able to operate, right? So your data should be such that it should be replicated to this in a way that your system still can go through any of the intermittent issues that your system has. Now let us go back to some important things in cap theorem. So let me just erase some of them. Right, or let me go to the other page. I think it would be better. I will just set this. Okay, so yeah, so so according to the cap theorem, any distributed system needs to pick two out of these three properties. So any distributed system cannot have all the C, A, and P, right? It cannot have all of them. It either has to choose CA or AP or CP. This, or this. But CA is not really an option. This is not really an option. Always remember that you that you cannot have consistency and availability at the same time in a system, because you will always have to support partition tolerance in your system. So if you have to support partition tolerance, the only choices is availability and partition tolerance, or consistency and partition tolerance, right? So you can reframe a cap theorem as, in the presence of a network partition, a distributed system should either choose. So if there is a network partition, right? So it will always be so why I'm saying in presence of a network partition, it is evident that there would be a network partition in a distributed system. You cannot really have a system which doesn't have a network partition, because it is very common for nodes to stop communicating with each other due to some network issues, right? So you have to support network partition. So in presence of a network partition, the only choices you have is that in presence of a network partition, a distributed system must choose either consistency or availability, right? Now let us think about why in case of a network partition you cannot have both of the consistency and availability, and you have to either only choose one of them. So as we discussed, that you can only ensure consistency or availability in case of a network partition, right? Now let's understand this, why you can either choose consistency or availability with an example. Let's say we have a system we have a multi-master architecture, and data can return to multiple nodes, right? Let's say that there are two nodes, there are two database nodes, right? And basically something like we have a client and we have a database, and there are, let's say, 2 DB nodes, right? There are 2 DB nodes, node A and node B, and this is your DB basically, and it has multiple nodes within, right? Now, data can be returned to multiple nodes here, as you can see. It can be returned to A, it can be returned to B. Makes sense, right? Now, when a write is sent to A, node A syncs the update to node B. So let's say every time you give the write request to A, and then the node A syncs this write request with node B, right? And any read request sent to either of the two nodes will return the result. So we are only talking about write. When we write to A, and A syncs it with B, and any read request will return the updated result from either A or B, right? Now let's say if there is a network partition between node A and node B. Now let's say due to some reason, there can be multiple reasons, node A and node B stop talking with each other. Then the updates cannot be synced, right? So node B won't be able to know what was written to node A, right? And node A won't be able to know if B got the update. Basically, both have lost the communication, right? So now the behavior of either node, so behavior of node A and node B after receiving the write request will depend on now coming back to the definition. In case of a partition, like in case of a partition in our system, right, we can either choose consistency or availability. Now our system has the partition. Now the behavior that our system will be consistent or available depends on whether the database will prioritize consistency or availability. We can still continue to have choice. We have choice either to support consistency and availability, because now we have partition tolerance, right? Now, if we have to choose consistency, let's think about that. So consistency, as we discussed, that after a write is sent to the database, all read requests sent to any node should return the updated data. So what happens in case of consistency is, if you are writing something to A, then when I am reading, let's say there is another node C, then if I are writing something to A, then all A, B, and C should be in sync with each other, and any read request I will receive the updated result, right? So if I am writing x equal to 3 or updating any entry, let's say, into the database, then I will read from A, B, or C, I will get x equals to 3 only, right? Now in the case of a network partition, both node and node B, in case of a network partition, both node and node B would reject any of the write request. So if your system knows there is a partition and there is lack of communication, we will just reject the write request. We will reject any write request sent to any of the node. This what will happen with this, that the data of the both the nodes will remain same, and node A would have the updated, like, so in this case both so let's say initially you had x equals to 3 written, and then after that there was network failure and there was a write request of x equals to 2. Now node A, if you're writing to node A will reject, saying that okay, we have a partition tolerance, I am not going to update that to myself on night, since I am not able to sync that with node B. It will say fine. Now this makes our system consistent, because now if you are doing a read request to either A or B, you will get x equals to 3, right? So our system is consistent in this case, right? Now if we have to, so basically we reject any update request, right? Now if we have to support this was in case of consistency. Now in case of, if we have to support availability, it's okay to have inconsistent data. So if you're supporting availability, it's okay to have inconsistent data. So in the sense that node A, let me just go back to just undo a bit so that I can reach to my original diagram. Right. Sounds good. So let's say this, and there is an again there is a network partition. Yep. So now, as I mentioned, if we have to, if we have to, so we are talking about availability now. So if we have to prioritize availability, we can choose to have inconsistent data across nodes, right? So one nodes can have, like, some of the nodes can have stale data and some can have the updated data. So availability means that we prioritize node to successfully complete request, right? So available database also tend to have, basically availability doesn't, if you're choosing availability, we don't just really ignore consistency. We can have eventual consistency, but not like at the same we cannot have consistency at the same moment. Eventually our system can turn into a consistent state, right? So which means that after some amount of time, the network part, if the network partition is resolved, all the nodes will again get in sync with each other, right? So in this case, node A will receive, let's say in this case, node A receives the update, and after some time node B will be updated, right? So in case of availability, we have prioritized node to successfully complete request. So earlier what happened was we ignored or rejected the write request to make our system consistent. But to make our system available, we will write to A, and we will return success that okay, we have returned, making our system available at all times, right? And as soon as this network partition goes away, we will again sync A with B, and our system will be eventually consistent, right? Goes away. Fine. Now this is why we cannot have uh like availability and consistency at the same time in case of a partition tolerance. So if you might think, what should we prioritize, consistency or availability? So depending on what matters to in the system, we can do that. So if we are working with a system that needs the up to date data, we better need to prioritize consistency. And if fine to have like data out of sync with various nodes, but we need our system to be really available, then we can go with any of the databases that support availability over consistency, right? So there are various databases that we have for, like, that prioritize consistency and that those prioritize availability. Let us talk about those. So for consistency, I think for example, SQL databases support consistency. MongoDB supports consistency. If you have heard about Redis, it supports consistency over, it prioritizes consistency over availability. So SQL, MongoDB, Redis, you can note them down if you want, and read through more about their architecture and how they support consistency over availability. We have Google's Big Table doing the same, and those who support availability over consistency, uh, then we are talking about Amazon's DynamoDB, which is a very famous database provided by AWS. So you have AWS DynamoDB, and yeah, Cassandra also lies into that category. And then you have CouchDB as well, that supports availability over consistency, right? So this is mainly about cap theorem. So you might have heard that cap means either choose CA, CP, CA, CP or AP. But really, if you talk about in the real world scenario, it's choice between CP and AP. because no matter what, you have to support partition tolerance, because a modern distributed system will have partitions and will have network failures, and you will have to support that, right? So that's about it. That's just about the cap theorem. If you really have any doubts, then please comment. I will try to address them. And if you want any other video, if you want to know more about any of the topics related to cap, please comment that as well. And if you please like my channel, if you like my content, share it with your friends, subscribe to my channel. It really motivates me to make more good content. I have already made 3 videos before. This is my 4th video in the system design series. I will continue to make more and more videos so that I can help you in your system design preparation. But please subscribe and like. This will motivate me, right? Thank you very much. And stay tuned. I will make regular videos in the system design series. Thank you.